Hey everyone, thanks for joining me today. I hope you're having a great day so far in the first day of App Builders, even though I would have loved to meet all of you in Lugano. For this time, this remote edition will have to do, but we'll make the most of it, obviously. So let's just get started. Today I'm going to talk to you a bit about how to get started with Combine. I'm going to teach you a bit of basic theory, as well as some in-practice tips on how you can get started on your own when you get back home. Well, you're actually already home, but you got my point. So a bit about me to get started. My name is Shai. I'm iOS tech lead for a company called Get in Israel. I do a lot of open source work. The most notable projects are the Arc Swift and Arc Swift community projects, which I maintain. And I also manage the Combined Community organization, where I have a bunch of projects I'll talk about later in this talk. I talk in a lot of conferences, such as this one, SwiftConf, TrySwift, etc. And I'm a huge fan of hackathons, and I even won a few, luckily for me. I also write and edit tutorials and books on the raywenderlich.com website. These are some of the books I worked on, and the last of them is the Combine book, Combine Asynchronous Programming with Swift, which I worked on with Scott Gardner, Florent Pillay, and Marin Todorov. Recommend it. I'll share a bit more info about it later in this talk. So let's just get started. What is Combine? I always like to start with the dictionary definition of something which is very complicated, like Combine. So Combine is really a framework which provides a declarative Swift API for processing values over time. And these values can represent many kinds of asynchronous events. I really want to focus on the word asynchronous here. So when we talk about asynchronous, what do we really mean? Basically, everything. Everything in your app basically is asynchronous. If you think about it, networking, KVO, even a user's input, tapping on a screen, all these things are events that happen over time and asynchronously. So we can really wrap all of these in something called a publisher in Combine. I'm going to share a bit more about what that means, but it's just a unified way to represent things that happen over time. So we have consumers that can subscribe to these publishers, and they can be notified when something happens. So basically, if I have a publisher and the publisher says, hey, I performed some work and I emit values as they change, I could have some consumer or subscriber that says, cool, I'd like to receive these values and be notified whenever that change is made, and they just basically communicate amongst each other. Our aim, we should aim basically to try and make everything a publisher all the things, but not really. I mean, the more publishers we have, we'll get better capabilities for our app. I'm going to explain what that means right now. Basically, if all synchronous work is represented under exactly the same interface, we expose a lot of really great capabilities. Today, when you consider UIKit and iOS development in general, we have a lot of ways to represent asynchronous work. We have a tap on a button that is represented by this IB action thing. We have a text property, which we can kind of listen on using KVO or just kind of adding a control event on the text field. And sometimes we do a network request and we're going to get some closure for the response back. So these are really different interfaces, and we kind of need to juggle between all of them to find the right one, and we have to sort of make them all squish together and make them all work together. When you look at Combine, what we have is just a unified way to represent all of these things. All of them are a publisher. So that means we can compose them in a really nice way, in a way that makes really powerful ideas and really powerful code that you can leverage for your app. So here are the two big buzzwords, reactive and declarative. So when we subscribe to a piece of information, as I mentioned, you always get the latest value from that source, meaning reactive, right? That means that if I'm subscribed to a location service, I can be notified when the user has a location or what is their latest location, etc. And that way I can keep my app up to date. Here's a quick kind of contrived example. I have a user that has $5 and they want to buy a product that costs $10. We have a can make purchase boolean. Is the user's balance sufficient to purchase the product? That is obviously false. They don't have enough money. Later on, we give the user some more money. And they now have 25 and the product costs 10. This should be true, but it's still false. And that's because can make purchase doesn't reflect the latest state of your system. It is a snapshot in time of when we calculated it back when the user's balance was 5. So really we can't count on it for state. If you look at this counterpart combine code, and you don't necessarily have to understand it at this point, we take a product price and we combine it with the latest thing from the user balance. And whenever each of these change, we map it to, is this bigger than that? And that way we always have this can make purchase boolean that reflects the latest state. And whenever either the price or the balance changes, we always get the truth out of that statement. So this is a really powerful concept that really defines what reactive means. A bit of combined theory to get us started today. So we discussed publisher very briefly, but I'm gonna kind of dive into it right now. So really a publisher is just a type that can emit a sequence of values over time. Again, it represents asynchronous work, basically. So it is a protocol that has two associated types, an output and a failure. And output is the type of values that the publisher can emit, while the failure is the strict type of error it can emit. That means you can say, my publisher only emits this kind of errors, or it may never emit any errors. So typed errors are pretty powerful in this case. We have 3 types of events that a publisher can emit to these subscribers or consumers. A value event and 2 completion events. Either finished, that means that the publisher finished without any issues, or a failure event, which means the publisher finished but something went wrong and we need to deal with it. So a publisher may emit as many values as it wishes, basically infinitely, until there is some sort of completion event. So for example, here we complete with a my error or with a regular completion event. So really, just because we have this dictionary where it could be either a value or a finishing event or an error event, only these 3 states, it's pretty easy to reason about, and it's pretty easy to design our system around these concepts. So a completion event basically terminates the publisher, and we won't have any more values emitted by that specific subscription to the publisher. The next up is a subscriber, which we also kind of touched on briefly. So if a publisher is a push-based interface, it delivers its values to one or more subscribers that consume these values based on their demand. Subscriber is a protocol that also has 2 similar associated types, the input and the failure. So as you can imagine, the input and output must match between the publisher and the subscriber, and the failure must match as well. That means that a publisher that publishes integers can only be attached to a subscriber that is willing to accept integers, and same for the failure, obviously. So really the only missing piece that we have at this point is something between the publisher and the subscriber so they can easily communicate between each other. And that thing is called a subscription in Combine. So really a subscription represents a single connection between a publisher and a subscriber. That means, for example, if I subscribe to a publisher once, I get a subscription, twice, 2 subscriptions, 3 times. Each time I subscribe, I get a different subscription. And the subscription is basically where the heavy work is happening, the delivery of the events. So the publishers provide a subscription to the subscriber using a method called receive subscription. So the subscriber just receives it from the publisher who creates a subscription for them and passes it along. The subscription then pushes the event to the subscriber. It has 2 methods to do this. The first is receive input, that lets the subscription send a regular value, and also the same for completion events like we mentioned before. So again, we have a publisher, the publisher creates a subscription, hands it off to the subscriber, and then they sort of communicate amongst themselves. So Another nice thing about subscription that it kind of encapsulates the work. That means that if you don't need the subscription anymore, you can just call cancel on it and that would terminate it. Another good way to do this is simply deallocate it. So once the subscription is deallocated, it would also kill the work, and it would be basically the same as calling cancel on the subscription directly. There's also one more really crucial role for a subscription, specifically in Combine, that we don't have in other reactive frameworks on the Apple ecosystem specifically, and that's called back pressure. This is a really fancy term that I'm going to try and simplify for you. The gist is that it revolves around different strategies, different ways to deal with publishers that emit too many values too rapidly for us to consume. For example, if I have a publisher that has 10,000 values over a single second, me as a subscriber might be very overwhelmed and have no idea what to do with so many values. So what Combine does, which is pretty interesting and also happens in RxJava actually, it transitions the control to the subscriber. So the publisher doesn't actually publish any values until the subscriber says, I am ready to accept some values. So the subscriber would say, please give me up to X values. The publisher would say, here are some values, and it would never give the subscriber more than they demand. And whenever the subscriber gets some values, it can adjust the demand and add more. Meaning, if I got 3 values, I'll be like, I want 2 more values right now. I'm ready to deal with more data. And we have some basic types of demand, which is unlimited, meaning give me anything you got, I'm going to deal with it. None, which means I cannot accept any more demand at this moment, please don't send me any more values. And up to max of some value, which means give me up to some limited amount of values. So the publisher must respect this contract. It means that if for some reason you make your own publisher, it also has to respect this contract, where it has to know how many values were demanded by the subscriber and only publish that amount of values. We also have one final type of publisher which is very interesting, which is called a subject. So a subject is really a special kind of publisher because it can kind of do both. It can kind of be a subscriber and a publisher in a way. It's really useful for bridging imperative code, and we have 2 variations of it. But first, what's the difference between publisher and subject? So for publisher, we can subscribe to it, but it's immutable. We can subscribe, but we can't add values onto it. It creates the values internally and publishes them outwards. On a subject, it is somewhat mutable. That means you can directly send values into this subject, and then whoever is subscribed to that subject will get these values. So really the values can be manually pushed by whoever manages that subject. So the 2 kinds of subject we get in Combine is a pass-through subject and a current value subject. A pass-through subject is basically a great way to represent events. For example, if I do a tapped button subject of values void that can never error, and then once the user taps, I'm going to do tapped button.send. So whoever subscribed to tapped button will immediately be notified that someone tapped it, which is very, very useful. New subscribers get the values only after the subscription. That means that if I just subscribed and a value was already sent, I'm not going to know it happened. I'm only going to be aware of things that happen since I subscribed to that specific subject. That's why it's great for representing events, because it's a future-looking thing. As opposed to it, a current value subject is really useful for representing state. For example, is loading. It's great for state because, as you see, it takes some initial value. Here I say it's a Boolean never a current value subject that starts with false. I can send different values to it, much like I could with the pass-through subject. But here I can also directly use a value setter, and it would be the same as invoking .send. And whoever is subscribed, again, will just get the values as I change them. In this case, though, whenever there is a new subscriber, they're going to get a replay of the current value. That's why it's called a current value subject. So if I subscribe to is loading, I'm going to know, is it currently loading or not loading? So very useful for representing state. To kind of summarize this theoretical section, we have a subscriber and a publisher that are attached to each other. Once they are connected, The subscriber is provided to the publisher using this receive subscriber method. The publisher creates this subscription thing to represent the connection between them and sends it off to the subscriber. From that point, the publisher is basically out of the picture, and the subscriber and the subscription talk amongst themselves. And then we have this entire back pressure game that we discussed. Basically, the subscriber says, hey, give me some amount of values. The subscription kind of delivers these values based on the demand, and the subscriber may continuously adjust their demand and add more demand, basically. And eventually, at some point, the subscription will send a finishing event, which can be either a regular finishing event or a failure finishing event. Awesome. This was a lot of jam-packed theoretical information, but I'm a huge believer in the fact that if you want to know something really well, you got to know the basic theory around it. So now that we have that, we can move on to our next section, combining practice. So now I have a bunch of these publishers that publish values, but what can I actually do with them in my app? There are two built-in ways inside Combine to consume publishers called sync and assign. Sync is a closure-based subscriber. That means if I get this publisher that emits hey there app publishers for values, I can use publisher.sync to get two different closures, receive completion and receive values. And then in each of them, I can do whatever I want with either the completion events or the value events. For example, just print them out. In this case, it's going to print got value hey there app builders, and then completed with a finished event. The second one we have is assign. Assign is really cool and useful because it is a bit like binding something to something, binding a publisher to some key path. If we get the same publisher of values, we can say that we want to assign every string value that is emitted from that publisher to the text of a text field. So we have a publisher that emits via the assign subscriber, and that's gonna constantly update the UI text field. So here we just have static for values, but imagine that being some dynamic thing that's constantly changing and the text field automatically being updated using this assign operation, which is super, super powerful and useful. So getting the values is really useful. We definitely want to do that if we have a publisher. We want to do something with the values. But it would be really cool if we could also control and modify the values that we get from these publishers. The way we do this is called operators, which is a concept that is familiar. It might be familiar to people coming from RX or other reactive frameworks. Basically, operators that you manipulate the upstream publishers and control the emissions in really expressive and flexible ways that let you create really complex logic. So by the way, when I say upstream means there's a publisher and there's a consumer, so up and down. So that's when you hear upstream and downstream, that's basically what it means. So if I have a publisher and I apply some operator to it, I'm going to get back this modified publisher that is transformed by the work the operator does on the original publisher. So really, if Combine would be a language, much like the English language, operators are the words that make it. So the better your vocabulary would be, the more words you know, the fancier sentences you can compose. So you really want to know these the best you can. So basically, operators are just simple chainable methods with many same-named variants in the Swift standard library. So many of them will ring a bell to you when you see them. You're going to see that right now. So here I have a simple publisher that emits 6 strings and can never fail. It has a never error type. And here I have this chain of chain of operators on my publisher. So we are already seeing a bunch of things we know here. We have compact map, we have map, filter, append. All of these are things that we use daily in the Swift standard library. Before we get started, this append at the end here I just graded out because append only starts doing its work when the publisher before it finishes, and that's going to happen at the end, so we're going to ignore that one for now. So let's just get started upstream to downstream, top to bottom. So we have the first value, which is 123. The compact map tries to convert it to a float, which it can do. Remove duplicate would check if this value is the same as the previously emitted value. In this case, there is no previously emitted value, so that's going to go through. We are sealing the value to 2. We are filtering that it's smaller than 4, which it is. And then we get this operator, drop first. And that one basically just drops the first value, which is this one, and then it would never do anything again. So this is an example of an operator that only does its work and then will never affect this entire publisher chain again. Let's go for the second value. We try to cast 2. We can. Is it a duplicate? It's not. Nowhere to seal it because it's already a whole number, and it's smaller than 4, so it goes straight to our output. Now we have another 2. Is it a duplicate of the previous value? In this case, yes it is. We just got a 2. There's no reason to have the same value twice, and remove duplicates helps us get rid of that. So that value is just dropped and isn't moved to the output. Then we get Swift and Lang. Both of them are strings. We can't convert strings to floats, so these will both become nil and be dropped by the compact map operator. And finally, we have 0.2. It is not a duplicate of 2. We round it up to 1, and it is smaller than 4, so it goes straight to our output. Now we got to our completion. So this completion is going to trigger the append operator here, which basically can take any of either a different publisher or an array or any sequence. So here it takes a stridable from 0.3 to 0.6 by 0, 1. So we're going to get 3, 4, 5 appended to the end of our publisher. And then we're going to get the finishing event. So operators, one interesting fact about publishers is that they are themselves types. So the first publisher we had is an integer. As soon as we have a compact map on it, this is the type it becomes, a compact map of a publisher of float. Then we have a remove duplicates of a compact map of any publisher, a map of remove duplicates of compact map, filter of, so anything you see wraps the thing that comes before it. And by the end of this entire chain, we get this massive, incomprehensible type that there is no possible way we can return from a method. Another huge issue with this thing is that we are exposing our entire chain. Whoever is consuming this chain knows exactly the ingredients we use to create it, which is something that you don't necessarily want to expose. Luckily, we have something that comes with combined that lets us sort of erase all that information. And that's called erase to any publisher. Once you use erase to any publisher, it's going to remove all of that information and return a regular any publisher with the final output and failure types. In this case, just an any publisher float and never, which is something nice and compact that we can return in our methods without exposing any of the information we want to keep to ourselves. Also, a nice thing here is that because we have this chain of operators, it's really kind of nice once you get to understand it. I can easily read this entire chain and get a glimpse of how this entire thing works. And this is, again, goes back to the fact that this is a bit of a language of different words. You kind of need to know them, kind of like you need to know different functions and methods in Swift. There's another nice operator that you might want to know about because it's useful for debugging, and it's called print. Basically, it would just print whatever event goes through it. So it's really useful for situations where you have values and you have no idea what's going on. Just put a print in there and you're going to get all the information you want. For example, here, I have a publisher that meets 2 strings, and it's going to uppercase every string. So I have the subscription to the first one and then to the print. We get an unlimited request for both of them, which again is this demand thing. Here I use the sync, which I'm not showing here, that's why it's unlimited demand. And then we have publisher, receive value app, uppercase, receive value, it's uppercased. Then builders, that's also uppercase, and then we get the finishing events for both of them. So this is a very simple example, but in bigger examples, this is really, really useful to get a good inside look into what's going on in your publishers. So since publishers unify how our asynchronous work is represented, we can actually use them on anything. So the easiest example we all think about is a network request. So we can do a map on a network request, and we can retry a network request for free. But we have more things that are asynchronous that are really expensive. For example, a video decoding session. That is also a long-running operation, and we can use the same map and retry on it. We get it for free for whatever piece of work we can wrap in a publisher. And that's another nice thing that we get for the fact that we can wrap everything in a single interface, and that interface immediately gets all of these free abilities, all of these operators, and all of these guarantees. Again, very useful and very, very powerful. Now I'm going to dive quickly into Combine Foundation and what Foundation offers to us to use for Combine. So Foundation provides really useful publisher abstractions to wrap common construct that we use every day. The first one is Sequence Publisher, which you kind of saw a few times during this presentation. I can take an array and do dot publisher and just get a publisher that emits each of the values in that sequence. Same thing for a range or a stridable like I showed you earlier. You can even do the same thing for a dictionary, in which case it's going to just emit key value tuples to represent the key values of the dictionary. Notification Center Publisher is another really useful example here. We can have a Notification Center default publisher for some notification name, and then whenever that notification fires, we're going to get a publisher. For example, here I have a publisher of the keyboard did show notification, and I'm printing out the end frame of that keyboard. So again, this is a little piece of information, the keyboard, but now it's a publisher. I can compose it with other things in my app and can create very interesting logic using the keyboard opening events with other events that are happening in my app at that same moment. A little intermission. About 9 months ago, I became a dad, and now baby Ethan is about as old as Combine, because I gave my first Combine talk around when he was born. That's when Combine was released. So we always have best talks, and he told me, "Hey Dad, can you tell me a joke?" And I'm like, "Sure, son." But he's very elitist about his technology, so he's like, "You have to do it with Combine or I'll cry." So I'm like, "Okay, if you make me, we definitely have the tools to do it." So for URL session, much like we have a data task, we have a data task publisher. So we can do very similarly to a regular data task that works with a closure. I can make a URL request and do URL session.dataTaskPublisher for a request, and we're going to get back a publisher that emits data URL response and a URL error for the error. We can then use sync or whatever other subscriber we want, and we can print out the resulting value or the resulting completion event. In this case, the string joke I got was, "Can a kangaroo jump higher than the Empire State Building?" Of course, the Empire State Building can jump. Haha, great dad jokes. Of course, I use the icon has dad joke because I'm somewhat of a new dad. I'm still learning all of my jokes. Another neat thing we can do and that we get for free in Combine is that for a publisher of data, we get this free decode operator. So once we have a publisher of data, we can immediately do .decode on that publisher with some decodable type and provide our own decoder. That can be a JSON decoder or a plist decoder or whatever you have. And then in our receive value, we would get the actual concrete joke type and not just a regular string, which is again very, very useful. We can also use Combine to observe any KVO compliant key paths. Again, for example, the content offset of a scroll view, the status of an AV player, or even the queue priority of an operation queue. All of these are super, super useful, and there are plenty more inside the ecosystem that you can just turn into publishers and compose them with the other publishers in your app. There's one more tree that is masked as a property wrapper, which is probably the one you know the most because it's very popular at this point with SwiftUI, and that's called @published. So @published basically wraps a current value subject. It takes an initial value and you can access it just like a regular value, just access the is loading. But if you prepend the $, you get a publisher of that type and you can subscribe to it just like you would any other publisher. Here I'm just doing a map and flipping the false to true or the true to false like a toggle operator, and then I'm printing the opposite of loading is something. and I still get the same capabilities. I can mutate is loading directly, and that would immediately publish that change to all of my subscribers. So that's actually really, really useful for a lot of use cases. You might already know that one. So from that, I want to take a really quick intermission into how Combine drives Swift UI, basically. So really, Combine's capabilities are really deeply rooted within Swift UI. The fact that they were both released in the same year is really not a coincidence. Swift UI needs to know when things change, and Combine knows how to publish events when things change. So those two communicate really well together. So I'm going to show you a couple of examples of how Swift UI uses Publisher under the hood. For example, observable object. So we look at the protocol, and then we see that we have an object will change publisher, which is obviously a Combine publisher. And the object will change is using that one. Then we have observed object. That one under the hood uses an observable object, which again uses a publisher. We then have the environment object, which some of you might know, that uses, again, an observable object, and the wrapped value is also the object type, which is this same observable object using a publisher. And also, the view has an onReceive modifier that you can provide a publisher to. And that means you can perform some action in your view whenever that publisher emits some value, and you're going to get that value whenever there's a new value published there. This is just a really minor show of display, kind of. There is so much Combine embedded inside Swift UI. So that's why I always say that it's really good to know Combine. Even if you're not going to do the hardcore Combine stuff, you want to know as much as possible. So when you get into some corners of Swift UI, you know what's the nice ways to deal with them. I want to talk a bit about community around Combine. So Combine conceptually builds upon many existing projects and the reactive stream spec in general. So ones that are very popular in the Swift ecosystem are RxSwift and Reactive Swift, which you might know of. So if you already work with either of these, you basically know Combine. Yes, there are a couple of differences, but these are basically all the same things. You have back pressure and other fancy additions, but these are all the same. Here's a quick list of differences. For example, for Combine, we have iOS 13 Plus, which is really the biggest issue with it right now. For RxSwift and Reactive Swift, we have iOS 8 Plus support, which is insanely, it's really crazy and really great for older customers, but also great for just apps that can't afford going iOS 13 and up, which is most apps right now. For supported platforms, we have Linux support on RxSwift and Reactive Swift. None of that yet. And that's probably driven by the fact that these are open source and Combine is closed sourced by Apple. I hope they will open source it one day. I would be super excited to check that out. For UI binding, we have RxCocoa and Reactive Cocoa. We get all these nice wrappers around UIKit and Cocoa components wrapped as publishers. We have Swift UI. It's not really a binding, but it's just a UI framework in a way. And we have Assign, which provides binding, but it's not really specific to UI as well. And we don't get any publishers. The error model, we have typed errors in Combine, and we also have them in Reactive Swift. RxSwift actually chose to not do typed errors and use the regular Swift error for everything. And obviously, as I mentioned before, we don't get back pressure at all in any of the other implementations. I personally think it's a bit of an overkill. I think that if you use Combine, you will notice that you barely use that feature. It is for very specific use cases, but I can understand why it would be part of Combine in general. I want to highlight a few great open source projects with Contrive. Some of these are part of a community I manage called Combine Community. So Combine Cocoa is similar to RxCocoa and Reactive Cocoa I mentioned earlier. It just provides bindings and extensions for Combine around regular AppKit and UIKit primitives, basically. We have Rx Combine that if you come from RxSwift, it will turn your observables into publishers and your publishers into observables and a bunch of other nice things. So if you're in that migration path, maybe you would want to check that out. We also have combined data sources by Marin Todorov, similar to ARC's data sources. Basically, you can sort of bind an array of items to a table view, and whenever that publisher emits new values, the table is automatically going to get updated using the diffable data sources we got in iOS 13. We have Combine X. That one provides a lot of missing pieces that Combine doesn't have yet. Operators like with latest from and others that we got used to from other reactive frameworks don't exist yet. So the community kind of stepped up and did its own implementations. We also have a fresh one from a couple of days ago. The Point Freako folks released their Swift composable architecture, which heavily relies on Combine, because again, Combine is a really great way to wrap work, and work can be side effects or whatever you can think about. So check that out for sure. And also we have Timeline Combine, that's also by Marin. That's a really cool instruments tool that instrument basically. You can plug into your Combine code and see visually how values are being emitted, how your publishers are behaving. So again, super useful for debugging purposes. You can find a lot of these projects in Combine.community. We also have a Slack channel, and you can find us on GitHub. Please join Slack if you have any questions. I'm there, and a lot of other interesting people are there. And we are mostly friendly, so happy to help if you have any questions. If you want to learn more, two final resources for today. I have a relatively new YouTube channel, but it has some nice materials there. The latest two videos I have are a live stream of me creating a custom operator from scratch, and how to create a simple raffle app using Combine. So check these out at youtube.com/Shai'sSwiftBits. And if you want a more kind of guided educational path, you can check out the book that I'm one of the authors of, Combine Synchronous Programming with Swift, this nifty little bear here. You can get it from raywenderlich.com or bit.ly/getcombined book to support our work. And with that, thank you very much, and I really hope you enjoyed this talk. I'm gonna stay here obviously for Q&A. Feel free to chat, feel free to send any questions, and feel free to reach out on social media.